Hello, friends. I got like 2 of you to say hello. Thank you for coming and learning a little bit with me of this wonderful title. It took me a while to come up with what I wanted to call this talk because, well, all of the ideas I threw out sounded a little convoluted and long, like what I wished I knew when I started coding, specifically on how to be more secure. It's a little long, and it doesn't really fit nicely in a social media tweet, so I settled on Defensive Coding Bootcamp. So, before we start, you have a little bit of time to decide if you want to hang out with me, okay? So, this is roughly what you're going to get out of this. Helpful tips on how to be an incrementally more secure developer, some examples of scenarios you want to avoid, useful non-language specific knowledge, and kind of like a quick starting point or checkup before your next project. Because the reality is, somebody who is a security professional is not usually committing all of the problems that we're seeing out in the world. It is us. It's the normal developer that has a project to do. And so this is just to kind of give you a gut check. These are the things I wish I knew when I started. I started coding in a boot camp, hence the name. I didn't go to a formal education. I just got tossed right in and asked to make banking software. Right, and then I moved on to insurance software and lots of personally identifying information data that I definitely did not handle properly. But there was no guide for that. It was just, here's what you can do. No, here's what you should do. So these are just gentle, like a gentle primer on how to do this. One thing I want you to take away is that your perception will shift as your experience grows in this area. Because the further along I go along this path, the further into discouraging and realistic I fall. Be aware that insecurity, often, there is kind of a learned helplessness that can hit you, especially the more experienced folks, like the more that you see that is happening in the world that you didn't understand previously. It feels like you're just a small percentage in terms of actually grasping the subject matter. Because the realm of possible attacks is always shifting when somebody's going after whatever it is you are building. But don't worry, after a little bit of time, you're going to get to that mastery achieved. I'm not there yet, but I'm definitely well on my way. I'm just trying to bounce from that second little dip there. Is anybody already achieving this mastery? Exactly. I see no hands. So what I do is I deal with identity. And identity is one tiny little part of security. There's so many different pieces we need to know. It feels like you have to be an expert database administrator, an expert algorithm creator, an expert security in everything. But the reality is that we all kind of have to know little small pieces. So these are the small pieces that I think everybody from junior all the way up to senior level should just keep in mind every time you create a project. Don't always build it yourself. And this is so hard for me because I did it all the time. I want to know. I'm a strikingly curious person. And because of that, I wanted to deep dive down the rabbit hole to figure out how something works. And that's great for your edification and education. But don't take too long at it, because unless you're going to just make that your hobby, it's going to take an awful lot of time and it baits you. The more that you start learning, you're like, ooh, I could do this and I could do this and I could play with that. And before you know it, your paid job is like, why is it taking so long to just build that login component? Because you want to know all the things. I used to write a lot of code, and I didn't know that the more code you write, the more bugs you have, and the more security holes you have to handle. Coding at a framework level is going to yield more secure results than rewriting a lower level module. Again, it depends on your role, but we're talking to most of us that are getting paid to write software for some sort of business purpose for a living. All right, so that's the first one I took away. Don't always build it yourself. Here's another one. I bet everybody in the room does this, yes? With any sort of shared credentials, you should understand that they could leak, and be prepared with a process in place to rotate them, meaning the keys that you have to various parts of your system. I'm going to give you some examples here. just to look at how fragile all these systems are. This breach was done by very sophisticated attackers who exploited a mistake in how CodeCove built Docker images. They used this to modify a script which allowed them to send the environment variables from the CI of CodeCove customers to a remote server somewhere. I wish I could say this was the only big strong example I have, but I have others. I'm going to just stop with one for now, just to let it sink in, that it doesn't actually really matter how much you trust your password manager, how much you trust the company that you decided to sign on with for some third-party system. You have to have a way in place to very rapidly rotate the keys that you have so that should something like this arise, you can at least stop the bleeding, so to speak. If you're interested in reading a little bit more about that breach, I've got a URL there for you. The next thing I learned that I wish I'd known earlier is a little bit of a killjoy as well. Are you noticing a trend here? Going down, right? Be skeptical about the new library in the block, and this is against my nature. I am so excited about whatever's in beta that's coming out. I definitely dove headfirst into voice with Alexa and Google Assistant very early, before there was any sort of concerns about data privacy, and found out pretty quickly that at the time it just wasn't fully baked. Obviously, over time, those things get worked out, but it takes years, literal years, to bake in a little bit more security. Using new and immature libraries can yield poor results, even though they are exciting. You don't know who wrote that code, especially if it's open source, unless it's just one person. And if you can't trust that code on some level, you should not include it in your project. So vet your libraries carefully. Popularity does not mean quality either. So is there more than one committer to the project? Are other popular frameworks using it? Has it been backed by any foundation in the event that the single maintainer gets hit by a bus? These are all good questions to ask. What happens if this project suddenly stops being maintained or goes away? And it's a little cumbersome because you just trust something that you've used before because you used it in a hackathon, or you saw it on a YouTube video, or you just read it as an option in a doc site. But you still need to vet each piece of the libraries that you did not write. So while I don't think you should write everything from scratch, you still need to vet the ones you do choose. Has anybody seen something that looks like this before? One person, great. While it's true you won't always know what you don't know, the majority of the top 10 security issues that developers face has not really changed much since at least 2017. This means that you can familiarize yourself with what they are and curb probably about 80% of these. I'd just like to point out that we still have SQL injection on this list. And of course, if a lot of you do the framework I do, which is .NET, we definitely touch SQL, or at least we have in the past. What is it about what we're doing? Are we missing something? Is it that SQL itself isn't secure? What's going on? And it's just interesting to see how things have slid in and shifted over just a few years. But in general, if you can learn a little bit about these, you can probably stop a bunch of the issues you've already got going on, and not to mention, you sound incredibly intelligent to the rest of your team. But you are at the mercy of the architectural decisions of the places that you worked, at least for the first parts of your career, because you don't question the status quo, you don't know if what's happening is supposed to happen in that project, or if you just aren't grasping it. So then it becomes something that you lack awareness of in your skill set. But I promise you this, security is the time to question the status quo always. If you don't understand how we are storing something, ask the question. Just to make sure that I know that we aren't being insecure about something. It sounds like you're just double checking rather than being combative, or that you just don't understand how that flow works. It's always the time to check. A good example of this is the first time that you see any sort of personally identifying data being stored in plain text in a database. Please ask why they're doing that. In certain countries, it's quite illegal to do it. In others, it doesn't matter. And it depends on what country that was developed in, and you have to just ask the questions in the beginning. If you just challenge the current status that you've got going on, even just like with the rotation of keys, again, you will start becoming more trusted, and you'll look even more smart than you already are. But I caution that your stack can obfuscate reality. Don't be afraid to challenge the assumptions of the stacks you have learned. It's very likely that the things you have learned are one possible way of doing things and not necessarily the best way of doing them. Particular frameworks and opinionated architecture approaches are everywhere, right? It's better to understand how your framework fits into the bigger world of code outside of just your language or framework. How is this contract supposed to work? That is a problem when you're trying to understand why what you are building is insecure, because some of the frameworks go too far into covering up what is happening and like obfuscating that flow. So you end up completely trusting how your framework approaches security, and you often don't have the ability to audit it. So while, again, I don't recommend you build especially secure components from scratch, it's important that you understand how it works. The example I'm going to give here is OIDC. OIDC stands for Open ID Connect, which is an extension of OAuth. If you just want to know how to add a login box, you can certainly Google that, and you can add third-party components to it, and that's great. But do you know that there is more than one contract extension for OIDC? Did you know that there are several new ones coming out for OAuth 2.1? Do you know you have a choice as to how you hook things up? You don't have to use SAML, I promise you. But you wouldn't know that if all you're trying to do is say how to get a login box to work in .NET 7, right? You're just going to be presented one flow, one hello world example. There's nothing wrong with that, but it might not work for your use case. What is your throughput? How many users do you have coming through it? How often are they going to be logging in? How are they going to change? You might need to change your payload. You might need to change a little bit of that flow. And just because you have one library that's implemented in your framework doesn't mean that that's the only way that is possible for you. So sometimes it's better to understand the overarching way that the internet trades information and does flows in browsers. If you're used to using an ORM, you're used to all of the wonderful built-in security, and likely it won't expose you to SQL injection, probably. But some of them allow you to build a custom where clause, yeah? And you aren't often aware of the security vulnerabilities of that at all. Or you somehow interface directly with a database, and you haven't exercised those muscles of security fencing for a while, and it's easy to get things to work and not realize that you just open yourself up to injection attacks because you custom built your call into the database instead. This is often why I love my database administrators who are like, let me build it and I'll just give you something to call. But what if you're it? You are everything. You get to be the chief cook and bottle washer and paint all the pretty pixels plus the database and write the algorithms, right? So how do you have time to be an expert in all these things? It's just a lot. If you're going to do any sort of custom work outside of the main use cases that an ORM is for, just let that be a red flag to you. If you have to build a custom where clause, you just need to be careful about what you're taking in. Same thing with regular expressions. Lack of tests is so surprising, and yet I definitely started coding without writing any of them. So I thought I would include this for all of you. End-to-end tests that test the UI are important. A lot of places have no tests, and it's so tough to know if a vulnerability can get through if you're not set up for tests in the first place. So step one, please, even if it's an existing project, put tests in place for basic things. Secondly, put a section that's just tests for security. can you do a SQL injection attack? You start with the OWASP top 10. Look at those 10 and say, okay, let's just at least see if we can hit these against it. It's a good basic place to start, and it will, any security professional that comes in and looks at what you have later will be like, at least they put in the OWASP top 10 vulnerabilities. I appreciate this developer. You got to know which tests cover the security scenarios, not just your pass-fail for your business logic. It's got to be more. So my suggestion is to organize security-related things into one section or region. You know, I never locked my first API down so a user could only see their data. And people could just type in a different ID in the URL and see other stuff just to see if they could do it. The first time that was brought forward to me, I was a mid-level engineer, and I was pretty embarrassed because they decided to show the whole company on our Friday meeting. Like, did you know that we can do this? Now, they didn't say it was me, but I was the one who definitely worked on that API. So they just wanted to demonstrate how concerned they were about it. Ugh. Fun times. Securing your app is one thing, but securing your data is like a whole other thing. Frameworks usually give you some of this stuff for free, but you generally have to write custom code to secure your data itself. So locking the front door is great, but then once your data is inside your database, who can get it out? Do you trust any call that comes in? How is that architected? What if somebody else were to get to your middle layer, your API or whatever you've got going on there? So it's not just about the front door, it's not just about your login box, it's about everything else on the layer. My suggestion is to make it a little bit more difficult to get through by locking each layer down and making sure that you don't trust the boundaries across them. And that's a little difficult because what we see in examples for this is how you integrate with Blazor or something else is not set up that way. It's set up to make it easy for you to get started in 15 minutes. The problem is that it doesn't talk anything about zero trust. It doesn't talk anything about what if somebody else pushes a PR that immediately goes out to production. What part of this could we lock the doors in? Much like a boat that is sinking, you know, if you start closing the doors to some of the hull, maybe you can save the boat and just kind of centralize the leak to just one area. So keep that in mind as you're architecting, that you may not have complete control over each layer at some point. Maybe you do right now, but that may not be the case later. So don't trust yourself that once they get past the front door, everything is great. Don't assume popular tech is secure by default. Why not? Aren't they popular because they're great? I have a secret to tell you. Kubernetes secrets aren't really secrets. Some of you know that. They are base 64 encoded strings. Look into the tech behind the name and understand how to use it, but understand what it is and what it's not. We have a lot of misnaming. Terminology is hard. Naming things is hard. But just because it's called a secret doesn't mean it is. Make sure you look into the tech behind it. There is more than one way to approach authentication. I hinted at this earlier. Authentication and authorization is incredibly confusing right away, not just because they both start with A. And the different ways to approach it, which is like, you could do it with SAML, you could do it with OAuth, you could use WebAuthn, you could use basic authentication, but don't. And understanding those flows is so critical for beginners, because you're the ones who are tossed at a project and say, fix this thing, or implement this. So if people don't understand a flow, regardless of the stack you're in, please make sure you make a decision which flow is the correct one and why, before you even look into, well, that's because I've got a Java library that does this really easily. You need to know why you are choosing the flow you are. There's more than one way to approach it, and it might be a lot more secure for your scenario than another. Something else that I learned is that incorrect encoding and serializations are an issue, and they're definitely ones that I've caused. So I give you no information that I have not completely done wrong. I just want to give you a little bit less pain along the way. Because the term encode has been used in the past to denote encryption and may still carry that meaning outside of a technical context. But in the software world, it's only meant as a data handling mechanism that never provides any measure of security itself. While encryption is meant to guarantee data confidentiality, some modern encryption algorithms employ additional strategies to also guarantee data integrity, sometimes by means of embedded hashing algorithms, as well as authenticity. So there is a difference between encryption and encoding. I want to give you a couple of examples that OWASP has on their websites of maybe things you should and shouldn't do. I'll give you a second. Smart coders don't read manuals. Just keep adding bytes until the algorithm stops throwing exceptions, or just save yourself time and cut and paste from a popular coding site. This looks like a good start. I'll give you an example scenario from the site. A React application calls into a set of Spring Boot microservices. Being the functional programmers they are, they try to ensure that their code is immutable. The solution they came up with is serializing user state and passing it back and forth with each request. An attacker notices the R00 Java object signature and uses the Java serial killer tool to gain remote code execution on the application server. Here's another one. PHP object serialization is used for a PHP form to save a super cookie loaded with data. It contains the user's ID, role, password hash, and other states. An attacker modifies the serialized subject to obtain admin privileges and tamper with the data. The attacker changes the serialized object to give themselves admin privileges. How many times do you think I have personally caused this problem? Different frameworks, and I didn't even think about it, because all I was doing was interpreting what was sent over in that cookie. I wasn't even checking to see if they really had that role, they were supposed to be there. I didn't do any of the checking. Again, I won't give you any advice that I have not needed to take myself. So don't use insufficient hashes, because many cryptographic algorithms and protocols should not be used, because they've been shown to have significant weaknesses or are otherwise insufficient for modern security requirements. I've got a list for you. Would you like to see what you shouldn't use? Yeah. That one? Anybody using any of these? No, you are all very secure. Definitely nobody's using the SHA-1 hash, right? What about the code you wrote a few years ago? Are you still using it in a project? Did you use one of these? Do you know that now the code you wrote before is not safe and you need to revise it? I bet you don't have a revisitation moment to all of the code that is just working out there, unless it has a bug that causes an actual friction point for your user. Just because it's available doesn't mean it's safe to use. There's a lot of hashing algorithms, specifically within different frameworks that I don't know why they're still there, but they are, and you can use them. But don't. Just take a look at what is the latest one, at least each time you start a project. What is the best hashing algorithm to use now? Because it's not always safe or secure. Maybe it was at the time, but it isn't anymore, because computers have gotten faster and attackers have gotten more sophisticated, so you just can't use it anymore. It doesn't mean that what you did before was wrong. It just means that it is no longer right. Has anybody heard of Log4j? Because code you wrote with time will become insecure. Security is ever shifting and changing, so it is exhausting and endless. Yay. How do you know if the thing you wrote last year is still secure? There is a framework that's good for this. Framework meaning a guideline. It's called NIST, and they write standards every year based on that. PCI is also a good one to use for leverage with your non-technical people and your management team to be proactive instead of reactive to vulnerabilities. So use the industry's current standards to back up the need to attend to and maintain your application. We should all be doing this at every one of our jobs, but it's often just not on the roadmap to revisit our currently working, not broken software. Just remember, the decision to execute is not in your hands. So don't take it to heart. It is a company risk decision. Your job is to explain the risks and bring the evidence. If you're interested in how to start with some guidance on that, the cyber framework is great. What's nice about this is the framework is a voluntary guidance and is based on existing standards, guidelines, and practices for organizations to better manage and reduce cybersecurity risk. In addition to helping organizations manage that, it was designed to foster communication between internal and external organizational stakeholders, meaning it's adopted worldwide and volunteer-driven just to see if we can find a language to go between somebody who gets to decide whether or not you're going to spend money on refactoring and whether you're not. Lots of really good FAQs for small businesses as well for things to keep in mind. We all do this, so I can skip this slide, right? Yes. Don't ever believe what's coming into your system, friends. Always validate. Think about trust boundaries. If you've never heard that term, that's okay. Google it right after that, but that is much longer talk than what I got today for you. When data basically flows across a trust boundary from outside your system to inside your system, that's one we can identify, right? You shouldn't trust that. You need to validate. Where is it coming from? Is it who they say they are? All these things. But do you trust that your database hasn't been breached the other direction? How would you even begin to have that conversation? So I'm giving you questions to raise within your software teams. How do we know that a bunch of data hasn't been changed? Can we do anything at the application level? What do we do with this? Should we check timestamps within the database? Questions like that. Sometimes the answer is there's nothing we can do, but oftentimes there is something you can do. You should always trust regardless of which boundary you're crossing, and it doesn't need to just be top down, it can be bottom up. Something else I learned is that string comparisons are red flags, but I liked doing them. How can you get string comparisons wrong? Well, a lot can depend on character encoding and your regular expressions missing some malicious cases. Yes? There are many out there, and OWASP has a great example of what that means. So don't just copy and paste things that are out there, just take a good look at what should be allowed, especially when it comes to account creation, etc. Don't assume the user will follow your use case. Usually means something very different to folks who do UX and UI, right? But what it should mean to you in this instance is that you should never assume you know the motivation behind what the user is doing. There are cheat sheets out there that inform a hacker how to input SQL injection. They don't have to be an expert at it. So try to account for all of the possible edge cases for a nefarious user. But don't worry, I have some good news. You can be lazy and secure. Do input validation, that's a good one, right? For instance, only allow letters in a username field. There are shortcuts. You don't have to hand code all the things. Using a vetted third-party authentication option does remove a lot of risk from your shoulders, as long as you look into it and make sure it's really doing the things you need. But there are pieces to this that can help you. It's good to kind of investigate what is being used at higher levels of security. I don't know what kind of projects you're all working on, but I've spoken to everybody from very sensitive government stuff to banking, and I can tell you that everybody has a different idea of what secure enough means as you're building a project. Oftentimes, hand rolling is so much less secure that even governments have acknowledged it, and they instead are using vetted third-party pieces or components for their application because they just don't want the risk. Or they would love to also, hand in hand, grab another company who created that module to be legally responsible if anything happens. So don't be surprised if you don't get to make the decision about whether you get to hand roll all the pieces of your application or not. It might just be a legal decision. The good news is, at least you didn't have to write it, right? You just needed to hook it up. This is a really interesting discovery for me. You need to understand where assumptions truly come from. I would love to share an example from somebody who is a pretty amazing ethical hacker, and his story was fabulous. One of his biggest screw-ups was related to physical security, not digital security. So he made a bunch of threat assumptions that might be the same in the US or the UK as South Korea. Okay? The threats like ram raiding, which is a car driving into a window at a shop and stealing everything, just don't happen in Asia. So he was countering threats that aren't even a cultural norm for them. So what may be normal for you may not be in another place. And I thought that was interesting. But regardless of how special you think your area of expertise is, most of security is a common body of knowledge. On the other hand, there's quite a bit we all have in common, though a specific industry might think they're more unique than they really are. The example I can give is that most automotive companies feel that their industry is in a silo. Okay? They feel like their requirements are specific to their industry, and if a vulnerability is not labeled as automotive specific, they don't feel they need to pay any attention to it. 80% of security is a common body of knowledge. It's the 20% layered on top that is specific to your industry. So if you follow, again, a plug for the OWASP top 10, you would have covered 80% of security vulnerabilities in your automotive software. And sometimes it's a little more than that. But in general, you shouldn't ignore something just because, oh, that one's in the browser. Do we use the browser for anything in the car? Do we use this browser for anything on this on-prem system? Maybe you didn't think about it, but oh, yes, we do. Is there a way that a hacker could exploit that vulnerability specifically for your system? You should just always look at it. Even if there's nothing to be done, you should look at it. So how do you keep track of all of this? That's a lot of responsibility. So are we supposed to just like read a newsletter of the hack of the day, this vulnerability of the day? Usually, unless it's a zero-day situation, you can just schedule like a yearly security review of all your existing projects, and that's enough, especially because that's what gets updated on the NIST site and OWASP Top 10. This last one was hard for me to grasp, and that was to get my head out of the code. Because the more you're in the code, the less you can see the big picture of how somebody's going to get inside your system. Because when you're focused entirely on a project, you aren't paying attention to all the other places the insecurities are coming from. And if you're not sure what's going on, because either you didn't build it originally and you're just a maintainer, or you are not the lead on the project, then have a trusted person take a look at what it is you are doing. You need somebody that can look at the entire thing, and it cannot just be you. You're going to be an expert at the module you wrote, but you can't be on the entire project unless it's a fun one-person side project. So get another pair of eyes, one that you not only trust, but actively collaborate with if possible. There are no stupid questions when security is at stake. The only thing I have ever regretted is being embarrassed and holding in guilt about, oh, I don't really think this is very nice. I don't want other developers to see it. I'm just going to quickly push it and, hope for the best on a PR. Don't do that. Just ask questions before you push it. This is fun. Everyone has dealt with cross-site scripting errors, right? Most people do hacks to get around CORS. I think Scott Hanselman has a great article about this for .NET. Forget that they have a hack to go around CORS, and then they build the rest of their project around that being the working environment. So when a hacker comes in later, that then exposes it, and when you try to fix CORS, the vulnerability around that, suddenly your project is broken by design because you only built it around this hack to get around CORS. You see what I mean? So my suggestion to you is set up a secure environment before you code one line. Set up your production environment for the entire publishing. Set up your repo to be secure by default. Set up all this stuff. Set up CORS to work. Now start pushing your code. please. And that way you don't have to wonder if you need to go back and fix the hack that you put in place just to get something working so you can see a browser pop up for you. Verify that your environment has bare minimum security. Just the basic keep the lights on. Okay. Brute force attacks can happen to your projects. Sometimes they cost you money. Hackers will often hold databases for ransom just by running a list of commonly used admin passwords that still make the top 10 list. Admin is the most common database user credential, and it's not often changed. Yes, even today, even last week, I got to discover that for a friend's project, and I said, you didn't even fix the password? Ugh. He's like, oh, I was gonna do it later. It's also often not stored in a password manager, which is still better than nothing. Please don't put it in a Google Doc. These are basics that you can suggest to your network admin, DBA, or developer team handling deployment. Hey, did we just write this password down somewhere? Is it in a Trello board? Like, what's happening? Or maybe you use Jira. But whatever you use, it's very easy to just stick it in a Slack message or stick in a Teams message. And now it lives there. So somebody who gets access to the system can just search through all the history for anything that starts with admin. It's great. It happens so often, not because you aren't capable of changing a password and putting it in a secure password manager, but just because we're in a hurry. So if you start off your project by doing the right thing, you won't have to think about it again. You just set it up correct the first time and then go on your merry little way coding your project. But if something does go wrong, you have to say something right away. I wish I'd done this. Sound the alarm right away once you discover that a project you've worked on has been hacked. Send it up the chain and don't try to outsmart the hacker and be a hero. Once that happens, you might have to get a legal team involved, up to the owner of a company, and it's just very messy. So ask for help when something like this happens and don't interface with the hackers yourself directly. I never thought I'd have to put this in a slide, but then I definitely did the wrong thing, so I thought I would include it. I was just like, I know what to do. I know it went wrong. I see the hole. I'm going to patch it. I'll eventually tell someone about it. But I definitely want to say we are no longer secure, but there was a moment in time where maybe we were secure for a bit. It's so tempting because we like fixing things. Yes, I want to fix things. I also don't really want to be embarrassed about a project that I've been working on that I didn't see this hole. But there's so much legally going on, you have to tell all the way up. And the likelihood of you getting dismissed for that is a lot lower if you were transparent about it. Also, I've never met a developer who's like, yeah, I definitely was fired because I didn't, because I created this problem. Usually what happens is in a post-mortem, they say, why did your publishing framework allow that to even go through? Does anybody else look at this? Are there tests that you run? It might just be a systemic issue. It's not that you're human and you make mistakes or you just got busy or you weren't even focused on it. You had no idea. You had no training in how to deal with writing something very securely versus writing something fast. It's that the whole project was not set up for success in the first place. So by being transparent, you will display that to people who can make decisions about fixing that from happening again. I remember years ago that someone, I believe, at a large company made a little bit of an error in a CLI and definitely erased a bunch of data in an entire region that they were hosting. And instead of that person just getting fired, they were like, well, how could somebody at this level very quickly just type a few characters with no confirmation dialogue that they were about to change or dump a bunch of things? And so that is what grew out of it, and now it is a lot less likely at that company that someone will have permission levels to do that. It's very exciting when you get God-level permissions, but it's a big responsibility to be superhuman and never mistype. So now I'd like to turn the question over to you. What do you wish you had known about coding defensively? Because much like driving a car, you kind of got to at least protect your project a little bit from the traffic of what's going on. Just think about it for a second. You can tweet it at me, you can tell me afterwards, you can raise your hand and tell me right now. But what do you wish you had known that you discovered much later? If you're interested to get this deck, to show the rest of your team about, hey, did we at least do a couple of these things? I've got a deck for you. You can download. And this is what I will close on. We are the ones that are responsible for making sure that everything's locked up. But it really does get in the way of our creativity, right? It's not fun. I remember the first time I was forced to do test-driven development. I just want to make this thing work, okay? I'm not interested in doing all of these different use cases. It seemed really tedious. The good news is that usually coding securely doesn't have to be an overwhelming master course that you get at a university. At least at your level, which I'm assuming there are security experts in the room, but even we can learn a bit more. Just start with some basics and don't trust that you're going to remember to do them. Because once you put some things in place and you have everything around your repo set up, all your permissions set, then you shouldn't really have to think about this. Coding defensively doesn't need to be something that you have to think about every day. It's just something you need to consider before you type one thing into that IDE. Thank you very much for staying with me and going on our little journey. And as always, stay curious.